A good plan for when a supervolcano erupts. Don't forget to subscribe to Mystery News channel for more quality update. We've got a plan for when an asteroid is on a collision course with Earth, but the threat of supervolcanoes has gone relatively unnoticed. Should we be doing more to prepare for the distant, but inevitable volcanic winter? According to NASA, no known asteroids will threaten Earth for at least a century. We've got our collective eye on more than 98% of near-Earth asteroids. That's great for avoiding a real-world Armageddon panic, but there's potentially a much bigger threat a lot closer to home. It could be hiding right beneath your feet. There are about a dozen supervolcanoes on Earth. If one of them explodes, it will propel masses of sulfur into the atmosphere, cloaking vast swathes of our planet in dust and cutting off sunlight. Without sunlight, the Earth will cool. Crops will struggle to grow. People will starve and die. Nobody living on this planet has experienced a supervolcano eruption. The last was 74,000 years ago, at Mount Toba on the Indonesian island of Sumatra. Researchers believe that the explosion spewed ash across a radius of 4,350 miles. An eruption of that size could throw aerosols, fog, dust, and geyser steam, into the atmosphere, launching us into a volcanic winter. This would lower the global temperature by a few degrees and radically change the climate. In the northwest of America, magma bubbles beneath the Earth's crust in one of the world's biggest and most dangerous supervolcanoes. Scientists believe that a plume of magma rises from the very center of the Earth to power the volcanism of Yellowstone National Park's supervolcano. Known as a hotspot, this molten lava has caused 3 explosive eruptions over the past 2.1 million years. These eruptions created large cauldron-like depressions known as calderas. The largest caldera on Earth is now referred to as the Yellowstone supervolcano. The Yellowstone volcano has the potential to really wreak havoc, says Rosalie Lopes, a volcanologist and manager of the Planetary Science section of NASA's Jet Propulsion Laboratory. Before you let panic settle in, know that scientists believe a super eruption at Yellowstone is highly unlikely. It's going not to erupt tomorrow, and the chance of even witnessing one in our lifetime is infinitely minute. But should we still have a plan to mitigate a potential eruption? Could we? The short answer is, we don't know. We don't know whether we have or will ever have the capability or technology to stop such an event and whether there would be any point in trying. Any attempts could exacerbate the problem and potentially even trigger an eruption itself. We as humans don't have the capacity at this moment to stop a big volcano from erupting, says Yellowstone Park geologist Jefferson Hungerford. How would we stop an eruption? The underlying premise there is to take the energy out of the system, that energy being heat, and we can't do that right now. Spanning 3,472 square miles and 3 states, Wyoming, Montana, and Idaho, there is lots of heat energy in Yellowstone caldera. What would we do if a supervolcano erupted? Asteroid impacts which are less than 2 kilometers wide occur half as often as supervolcano eruptions, but they would both wreak similar devastation on our planet. Brian Wilcox, a senior engineer at NASA, was part of a group dedicated to defending the Earth from asteroids. He realized it was time we were as prepared for a supervolcanic eruption as we are for asteroid impacts. He got a team together at the Jet Propulsion Laboratory at NASA, including Lopes, and they began tentatively working out some back-of-an-envelope calculations. They wanted to start asking a radical question: could we drill into this volcano to mitigate a super eruption? This was just to start thinking if it's feasible to use the technology we have now to cool a magma chamber and therefore prevent an eruption, says Lopes. Yellowstone was used as an example for their study, but the work applies to any supervolcano. These eruptions are defined as being greater than or equal to a magnitude 8 on the Volcanic Explosivity Index.